Have you ever stopped to wonder how, in the blink of an eye, a message you send can travel clear across the globe? Well, today, we're going to follow that journey. We're going to race through the internet's invisible superhighways to see exactly how it all works.
I mean, just think about it for a second. You hit send on an email, you post a photo, you load a website. It feels instantaneous, right? Almost like magic. But behind that seamless experience, there's this incredibly fast, highly coordinated relay race happening. So how does it actually work? All right, to really get this, we need to meet the hero of our story. It's this tiny little bundle of information called a datagram. This one packet is about to go on an epic adventure, all the way from your device to its final destination. So let's follow it. Now, our datagram's whole journey is managed by a really crucial part of the internet's architecture. It's called the network layer. You can think of it like the internet's global postal service. It has one single mission: get the mail delivered.
See, the network layer doesn't care what's inside the packet. Nope. Just like the post office doesn't read your letters. Its only job is to get that packet from its source to its destination, even if that means hopping across dozens and dozens of different networks to get there.
So, the network layer basically does two very different but related jobs. The first is forwarding. That's the local, in-the-moment decision a router makes. A packet shows up, and the router says, okay, which exit do I send this out of? Routing, on the other hand, that's the big picture strategy. It's like the GPS for the entire trip that figures out the best overall path from A to B.
Okay, so to figure out that path, the internet uses two different philosophies. And honestly, the best way to understand them is with an analogy you already know: sending postcards versus making a phone call.
So on one side, you have the postcard method. The technical term is a connectionless service. It treats every single packet as its own individual thing. Then you have the phone call method, or a connection-oriented service, which is all about setting up a dedicated path first. The choice between these two really defines how the network is going to behave.
The postcard method is pretty much how the internet we use every day works. You write the full address on each datagram, you drop it in the mail, and you just send it off. Each packet finds its own way, completely independent of all the others. It's simple, requires no setup, but there's a catch. Just like postcards, they can take different routes, and yeah, they might even arrive out of order.
Now, on the other hand, you've got the phone call method. This one is all about preparation. Before any data is sent, the network establishes a dedicated path from start to finish, kind of like dialing a number and waiting for someone to pick up. This path is called a virtual circuit, and once it's set, every single packet follows that exact same route, which guarantees they all arrive in the right order.
And this table really highlights the crucial trade-offs. The postcard method is super robust. If a router fails, packets just find a new way around it. But trying to guarantee quality for something like a video call, that's really difficult. The phone call method is the exact opposite. It can easily guarantee that quality, but if just one router on its path fails, the whole connection is lost. The call drops.
So we know packets need a route, but how is that best path actually calculated? This is where we get to the real intelligence of the network, the brains behind the whole operation.
That intelligence is something called a routing algorithm. It's basically a piece of software that's running on every single router, and its entire purpose is to look at the whole network and calculate the absolute best path for a packet to take. Now, best could mean a few things. It might be the fewest hops, the fastest link, or maybe the path with the least amount of traffic.
And these algorithms, well, they've gotten a lot smarter over time. You can think about their evolution like this. They went from a system of spreading rumors and gossip to one where every router has a perfect, up-to-the-minute GPS map of the entire network. The really early internet, back on ARPANET, used something called distance vector routing. And that's the gossip method. Each router would only talk to its direct neighbors, telling them only what it knew. It kind of worked, but news of a change, like a dead link, could travel very, very slowly across the network, which, as you can imagine, caused all sorts of problems.
Today, most big networks use a much more advanced approach called link state routing. This is the GPS method. Instead of just gossiping with neighbors, every router builds and shares a complete map of the entire network. With every other router, everyone has the full picture all the time.
So how does a router build this amazing GPS map? Well, it's a 5-step process. First up, it discovers its immediate neighbors. Then it measures the cost or distance to each one of them. Next, it bundles all of that info into a special packet. Step 4, it sends that packet out to every other router on the network. And finally, Using the complete map that it's assembled from everyone's updates, it calculates the absolute shortest path to every possible destination. It's brilliant.
So there you have it. Our little datagram, guided by these incredible algorithms, makes its way across the entire world, hopping from router to router, and each one of those routers is making a split-second decision based on a constantly updating map of the internet.
And the scale of this whole operation, it's just staggering. The network layer successfully guides trillions of these little journeys every single day. It's this invisible, silent engine that powers our entire digital world, one tiny packet at a time. In the end, it all just comes back to that simple mission, source-to-destination delivery. But behind that simple idea is this incredible system of complexity, intelligence, and coordination that makes our connected lives even possible. The internet feels so seamless, right? Like it's built on a trillion perfect little journeys. But this is a system that's designed for resilience. When the map is wrong, it's constantly updating itself to navigate around failures. So the next time you click send, just remember the grand, invisible journey your data is about to take.